let me know. Okay, we'll discuss that later then. Let's just finish. So today we'll be looking at module 9, which is address resolution. Remember we talked about app before, which is address resolution protocol, just briefly. But now we will look at address resolution proper. So let me take us to the objective. We'll compare the rules of MAC address and the IP address. Describe the purpose of app. Describe the operation of IPv6 neighbor discovery. If you recall, we did said that for every communication to be established within computer networks, there must be a MAC address and the IP address. And we said once the MAC address have to resolve the destination IP address, it must do that through the neighbor discovery. That's for IPv6. And then for IPv4, it is through the app, which is the address resolution protocol. So for a system A to be able to tell where the destination device is either you're using the app for IPv4 to be able to resolve the destination, or you use neighbor discovery in the case of IPv6 to be able to determine the destination device. Okay, so MAC is media access control. You still recall, there are two primary addresses assigned to device on the Ethernet link. You have a layer 2. Remember, we said the MAC address on layer 2, precisely on the NIC part, which is the hardware part of the layer 2. And then layer 3 logical IP address used to send packet from the source device to the destination device. So for layer 2, it is frame, and then for layer 3, it is packet. So layer 2 addresses are used to deliver frames from one NIC to another NIC on the same network. If a destination IP address is the same on the network, the destination MAC address will be that of the destination device. So remember that if a destination IP address is on the same network, like the same domain, then the destination MAC address will be that of the destination device. So invariably what we're saying is that as long as it's within the same network, that's the reason why I gave us that topology to configure to be able to see if we can be able to ping across. So that you now know too well that for you to be able to ping or communicate, it has to be within the same LAN. And for any reason you be able to talk to any other system, it has to be through any of the routing concept, which will be more into CCNA2. So here at this level, it just lets you understand that if a destination IP address is on the same network as a destination IP address, then the destination MAC address will be that of the destination device, as long as on the same network. And so destination on remote network, when the network IP address on a remote network, the destination MAC address and that of the default gateway. Remember, we have mentioned the IP address, mentioned the destination MAC address, and the gateway. So the gateway is the process in which it will get to the destination. So we said here that first, this is what happened for remote network. The app is used by IPv4, that we have said before, to associate the IPv4 address of the device with the MAC address of the device NIC. So the app is used to be able to resolve that and then tell you exactly where the destination MAC address is. Then for ICMP version 6, when we say ICMP, we mean Internet Control Message Protocol version 6, is used by IPv6 to associate the IPv6 address of a device with the MAC address of the device NIC. Please remember when we say the device with the MAC address of the device NIC, we're still talking about your media access control. Okay. So the packet tracer here is identifying MAC and IP address. In this packet tracer, you complete the following objective. You gather PDU information for local communication. I would advise that when you're reading through the curriculum itself, try as much as possible to carry out these lab activities. It's there on the curriculum, but not as part of your assessment anyway, but just for your lab practice. So the app, let's look at app proper. Remember, app is address resolution protocol used by the IPv4 to be able to tell about the remote or the destination device. So here, a device uses app to determine the destination MAC address of a local device when it knows its IPv4 address. So the app provides two basic functions. It resolves IPv4 address to MAC address, that is one, and two, maintain an app table of IPv4 to MAC address. So on your system, you see that you can be able to check to tell the MAC address. Because the system, your laptop itself keep kind of IP address. That's an app table, which is more or less like a memory that, like a cache, that keeps all those addresses. So app functions to send a frame. A device will search its app table for destination IP address, corresponding MAC address. And if there's, look at the conditions now that help to ascertain that. One, if the packet destination IPv4 address is on the same network, the device will search the app table for the destination IP address. That's if it's on the same network. Once it's the same network, maybe they're on the same 192.168.10.0/24. Then we're saying that the device will search the app table. The app table is more or less like a memory table that keeps all the IP addresses of that particular network. And then two, if the destination IPv4 address is on a different network, like remote network completely, the device will search the app table for IPv4 address of the default gateway. Remember, if it's on a different network, one of the ways you can get to that network is through the default gateway. So it will search for the IPv4 address of the default gateway. And with that, it will be able to now tell where the destination is. But of course, the packet has to route through that default gateway and then be able to resolve the destination device. If the device locates the IPv4 address, its corresponding MAC address is used as the destination MAC address in the frame. So once you discover the IPv4 address, then its corresponding MAC address is used as the destination MAC address of the address in that frame. Remember, when we talk about frame, we're talking about your data having its header and trailer. If there is no app table entry is found, then device send an app request. If there's no app table, then it has to send. So there's a video for you to watch. I advise you to watch the video. So removing entries from the app table. So entries in the app table are not permanent. Remember, they are just temporary memory. And I remove when an app catch timer expires after a specified period of time. So it takes a while and then the buffer is cleared and then it builds up again. So the duration of an app catch timers differs depending on the operating system. So app table entries can also be removed manually by the administrator. So let's see how that can be done. Okay. Yes. So recall, your app is for IPv4, your neighbor discovery is for IPv6. Please note that, very important. So for you to view the app table, you just show IP app command on the networking device, and then it will display your app table for you. Then the app that's -A or -A command display the app table on the Windows 10 PC. So you can actually try this on the system to be able to see the app. So it gives you a guide of the different connections you have within that network. Okay. So app issues, app broadcasting and app spoofing. This app thing, which helps you to resolve your destination device and everything, is being used by hackers because hackers can be able to tell from one system and see that they can tell the destination device from your own system because your app table keeps track of all the systems on the network. So app requests are received and processed by every device on the network. Excessive app broadcasts can cause some reduction in performance because, of course, memory utilization will be high. App replies can be spoofed by a threat actor to perform an app poison attack. Enterprise level switches, including mitigation techniques to protect app attacks. Because during app is more or less like sending a request to be able to resolve the destination. So of course that keeps track of all the system on that network. So this is a packet tracer. You do the packet tracer, check it out and see. And then the IPv6 neighbor discovery. This is not far-fetched from what you have for the app for IPv4. But IPv6 neighbor discovery message protocol provides address resolution, router discovery, redirection of services. I told us what ICMP version 6 is, which is Internet Control Message protocol version 6. The ICMP itself is for version 4, but when you have the version 6, it's for IPv6. So neighbor solicitation and then neighbor advertisement message are used for device-to-device messaging such as address resolution. So the ICMTP version 6 router solicitation and router advertisement messages are used for messaging between device and router for router discovery. This router discovery is very important in the sense that when we'll be doing neighbor discovery, when we'll be doing configurations, more configuration in subsequent CCNA classes, you see a situation where when two routers are connected and one router is locked such that you cannot double click on it. You begin to wonder, say, what kind of topology is this? You can be on router A and be able to tell the IP address of router 2. In this case, it's not through telnet, but you can use neighbor discovery to tell that. So we'll see some of those kind of configuration in that area. Okay, and so you do the practice and then see for IPv6. The good thing about this is that you have this packet tracer giving you some kind of guide. So when you reading through the curriculum, you'll come across this packet tracer. When you click on it, you can be able to carry out the practice. Okay, and so that's for module 9. So module 9 is only addressing your app. As a summary, what it's talking about is app resolution for IPv4 and then neighbor discovery for IPv6. So when you go through that, if any challenges, you let me know. But basically, like I said, we'll be doing more and more of lab activities so that when you get perfected in that area, because that's the part where the students themselves will really want to do more. And of course, even in the industry, they want to perform excellently well through lab activities. In Cisco exam as well, priority is being given to the lab. So please, we need to sit up with lab practice. So this is module 10. Module 10 has to do with basic router configuration, which we've done so much in this area. That's what we've been doing for some time now. So configure initial router. So if you look at here, basic router configuration steps. Host name, I think quite a number of us should be able to do host name by now. And then secure privilege exec mode. You can say enable secret.
You are not display. You are not displaying.
Okay, we're not seeing it.
Okay, you are just displaying your folder. So.
Okay, can we see it now?
Yes, sir. Yes.
Okay, so let me just go back a step behind. So what I was trying to say in essence is that this is module 10, but module 10 is still talking about configuring your router, which is something that is already ongoing. So you will enjoy this part more when you keep doing the configuration. So you now discover that all these commands here will now make things handy for you. When you want to secure the privilege exec mode, you use enable secret password. When you want to secure the user exec mode, then you use the line console. Please, I want you to match each of these on the left to the right, so that in case you're asked any question, because I can bet you that even when you're writing the CCNA exam, you see questions that will come up and they'll tell you, okay, which of this command or which of this configuration addresses secure remote telnet. You know, they will give you different options. They might put line BTY 0 to 4. They might skip maybe this transport input SSH and put something else. So if you don't know that they're talking about secure remote telnet, you might choose the wrong option. So at every point in time, you should know that once you're talking about the exec mode, you're actually talking about the console. So if you password the console, you're actually looking at the user exec mode. So please take note of that. And then the host name enable secret, and then be able to configure, and configuration should be saved in the NVRAM. I quite believe that a number of us will be able to save our configuration right now. So if you look at your copy running config, startup config, this is what you use to save your configuration. Please, the more you practice, the more this command comes handy. With time, you just discover that everything will just be easy for you to do. I think, was it Mohammed Atami that was talking about banner? This is where you configure banner MOTD. I don't know if he's around. Mohammed Atami.
Yes, sir. No, I'm here.
Okay, so you could see the configuration for the banner MOTD. If you, sometimes you enter, it might enter, but it might not be registered on the network. So you need to be very sure that you're using the right character. You can use hash, you can use capital letter C, you can use all of that to be able to keep your information in between. And the essence of this banner MOTD is for some legal reasons. And so that if somebody maybe hacks into your network and you have a banner MOTD, you can actually sue the person. But if you don't have it and somebody hacked into your network, the person will just tell you he's carrying out an experiment or searching through the network, and then just did one or two things. So in some cases, in the court of law, the person might actually win you because he's saying that he's not seeing any notice showing restriction. It's just like having a house where the gate is open and there's nothing like out of bound, and then somebody just mistakenly walk in and say, "Oh no, I was just searching through and I saw the door open." So the banner MOTD is to create restriction and say this place is out of bounds, or unauthorized access only. So it's very, very important in router configuration. It comes under basic configuration. So I want to strongly believe that a number of us will be able to configure that. And then the interface. The interface comes handy at the global config mode. You just enter your interface, and then you can give a description, and then the IP address in case it's the IPv6, and then you issue no shutdown. Always remember to issue no shutdown to bring up the interface administratively. So here is a configuration for a typical network to configure the gigabyte 0/0 on R1 as shown. I also want everybody to practice this configuration and send. What you have here is the interface of the gigabyte network. You can see it here, this one highlighted here. And so what you do is that you enter the description, you can give it any name you want, and then the IP address. Remember, the truth is that you can have both IPv4 and IPv6 coexisting on the same network. So some topology is allowed. In the IPv6 address, you can see what you have there: 200:DB8:ACAD:10 1/64. I need to say this for the record. Of course, I will discuss with Sir Julius. I'm going to do a pre-recording on IP address generally, and then also send to us so that we can actually watch the calculations, see me do the calculations and all of that. So I will do a recording and then send as well to help us. So here you can see when you have this DB8 column ACAD, this is just an entire IPv6 length. And then when you have double column, it's telling you that at that point in time, every IPv6 address there is 0000 column. So remember, it's 16 bits per hextent, as the case may be. So when you type in the IPv6, then you do no shutdown, and then you
question, sir.
Yes.
In this address, inside the version 6 address 2001 along DB8. DB8 is not 16 bits.
That's why I was saying I want to do another recording for you guys. The DB8 means that there's a 0 before the D. That's why I was talking about the law of compression and suppression. In IPv6, you have it as 128 bit length. But in a bit of trying to make it simple so that you don't miss any of those numbers, the bit rather, the best thing is they now apply the compression rule, the suppression and compression rule, such that when you have any of the extents where there's 0 before any of the letters, that 0 will be removed. Yes, the 0 will be removed. That is where you are compressing it. The 0 will be removed on the ground that you're trying to read. The system will know, the network will know that there's a 0 there. But you who is configuring it is a way of trying to simplify the address. And then when you have like this one now, you have ACAD. You see, there's no 0 anywhere. And even if there's 0 in between, it is not applicable. The 0 must either be at the beginning.
It's clear, sir.
Yeah, is that it? Hello?
I said it's clear.
Okay.
Like the 10 now, it's implied that it's 0010.
God bless you. 100010. And then this double column 1 here means you have 0000 and column 0000. So when you have 000, that's 4 zeros, and you have column another 4 zeros, you collapse the 2 with double columns as long as they are next to each other. And what it means that if you count this, you have 1, extend 2, 3. Then when you come to this, you have 4. Then you now realize that the next one is the 8th one. That is between 4 and 8, you have double column. It means that this is 5 already. That means I have 3 hextents that are all zeros. I don't know if you guys are understanding what I'm saying. And those 3 hextents that are all zeros will be collapsed as double column. And this 1 you're seeing here means 0001. That's what it means. So the 3 zeros will be removed and then 1 will be left. And that means this one is the first usable. Of course, like I said, I'll do a pre-recording of that also to help us. So that's for this, but I would love us to do that configuration and see how it works. And then if you want to see what you have configured on that interface, you use this command show IP interface brief. What I tell my students often, each time we're doing stuff like this, is that as you're reading through the slide or reading through the curriculum, and you come across some of these commands that will help you to be able to debug your configuration further, you just have a piece of paper somewhere where you write them, because you now need them subsequently to be able to check your work, because sometimes you do troubleshooting. You think you have configured it already, meanwhile you have not. So you now want to check to see if you have actually configured a particular interface. The question is that what do you do? At the previous exec mode of that device, you just do show IP interface brief. It will display the interfaces and the IP address has been assigned. So if it's a wrong IP address, at that point in time, you remove it. And how do you remove it? You go to the interface again and you say no IP address. When you issue the command no IP address, it removes the old IP address, and then you can now reissue another IP address, because there's bound to be mistakes. So you can actually remove and then go ahead. And then another way also you can do show IPv6 interface brief, or you should, in the case of IPv4, it is show IP brief. So you use the brief for IPv6, you must use show IPv6 interface brief. Interface brief then to now give you the interfaces and tell you whether they are up administratively or they are down, and then the IP address. Because I would like us to, so in the next practicals we'll be doing, I'll be using most of these commands like show run, show IP route, show interface brief, show IPv6 interface brief, and then show you can use the show status and all of that. Now, the reason why you're using all this show is just to have more information about the content of that router or the switch. So the table summarizes show command used to verify interface configuration. So you can see here, it has been actually summarized there. So you can do show IP route, show IPv6 route, and then look at the explanation to match each of these commands. Like the first one is to display all interfaces, their IP addresses, and their current status. While the second one is to display the content of the IP routing tables that is stored in the RAM. And then remember, when we say stored in the RAM, we're talking about your running config. Your running config is on the RAM, and then your startup config is on the NV RAM. And then display statistics for interfaces on the device. So only displays the IPv4 address information. That's for show interfaces. And then displays the IPv4 statistics for all interfaces on the router, which is to show IP interface. So I would advise that you use this command and then see how it works. Quite interesting. Still on the show interface brief and route. Quite important. So when you're doing your configuration, you use that a lot to help you. So configure the gateway, default gateway. Remember, the gateway is the router interface that leads to the remote network. The default gateway is used when a host sends a packet to a device on another network, on a remote network. And once that is done, is just to, like what the topology I gave us is a typical network topology for gateways. If you see, you have to you also got to configure the gateway. I want to believe that all of us have done the assignment. So for default gateway on a switch must have a default gateway address configured to remotely manage the switch from another network. If you give the switch a gateway, you can be on a different network and in some cases telnet into the switch by typing telnet and then you put the IP address and here you go, you'll be in the switch. And then to configure an IPv4 default gateway on the switch, use IP default gateway IP address. So once you just enter, put it IP default gateway, and then you put the IP address on the global configuration mode. Please, when we say global configuration mode, we're saying after the privilege exec mode, you have the global configuration mode. So the very moment you do config T, you're actually operating on the global configuration mode. So that is where you assign the IP default gateway on your switch. So to be advisable, you do packet tracer troubleshooting on the gateway and all of that. I keep saying this, place more emphasis on that. Now, this video covered different configuration of the following: Cisco 4000 series router, Cisco 2900 series router, and then all these are actually in the packet tracer, so you can use any of them at any point in time. So what have we learned here? We've learned that to configure the device name, and I believe everybody could do that. Secure privilege exec mode, secure user exec mode, then the remote telnet, and then secure password in the configuration file, provide legal notification. And remember, if legal notification is the banner MOTD, and then save the configuration. So among others. So I want to believe that when we walk through this module 10, I think it will also come handy for us. But then you enjoy it more when you do a lot of practice. So as you're practicing with the topology, you have different topologies you're practicing on, it comes so handy. If you're not practicing, that is where you have a lot of issues. But when you practice, it's got all those commands we're talking about. They are not issues at all. Okay, so I will quickly just take on this module 11 and then take a break. And then we'll look at one or two topologies and then we can close it up for today. So if you look at what we have, if you're actually seeing my screen, this is module 11. Module 11 is talking about IP4 addressing. So if you look at the entire curriculum, it's talking about addressing. It means that you want to actually address these devices, the host devices, the intermediary devices, they all be configured using IP addresses. So it's either you're configuring them with IPv4 or you're configuring them with IPv6. So if you look here, The objective here is to describe the structures of IPv4 address, including the network portion, and then the host, and then the subnet mask. And then compare the characteristics and uses of the unicast, broadcast, multicast address, explain public, private, and reserve IPv4 addresses, explain how subnetting segmented network to enable better communication. Calculate IPv4 subnet for /24 prefix. I'm going to do a lot of introduction here with this slide, but then I also want to reassure us that I'm going to do a kind of step-by-step breakdown of how this is being handled. And then I remember vividly I promised us that I was going to give us a link to the old exploration 4.0, where you can do a lot of practice on IPv4 and subnetting. So I hope to do that tomorrow so that you have it and then you start practicing to see if you can actually handle that. So we have said that IPv4 is a 2-bit length, and then the network portion versus the host portion. And so if you look at an IPv4, typically, like what you can see on the screen, 192.168.10, a lot of people are kind of 192.168.10, engineers. But then here in this section, we will actually talk more on different other IP addresses, like the class A, which is 10.10.0 and all of that. And then the class C, which is 172. So it's not all the time you're doing 192.168. There are times when you have to do other classes as well. So when those questions come, you're bound to use the different classes. So you have the host portion and you have a network portion. The host portion for a class C, if you look, you see very well, the class C is the last octet. The last octet is where you have the host portion. That is where there's some variation. We're talking about by default, please. I'm looking at normal default IP scheme. It's actually at the last octet that you can change those numbers. Every other one will remain the same. You don't touch them because you're dealing with IPv4 class C. And then when you're doing class B, then you can actually touch the third and the fourth octet. And then when you're dealing with a class A, then you can touch the second, third, and the fourth octet. So for a default class C, you're always bound to use the last octet. That is where the variation. That's why you see we say .1, .2, .3, .10. We will not come down to this and change this one again. No, we will change this one under certain condition, which I'm going to explain. So the last portion is where you have your variation for a default IPv4. So what you could see here, this prefix length, if you also recall, we've been doing some configuration using /24. You'll be asking yourself, what does that mean? The slash there is actually what we call prefix length, or what we call slide notation. So another word for prefix length is slide notation. It tells you which network you're working with, either a class A or a class B or a class C, as the case may be. If you see 255.0.0 subnet max, if you convert it to binary, you see the first 255, if it's converted to binary, will give you all ones. Then .0.0.0, these are octets, so you spread them out for the 8 bits of zeros across, and you can see this. Then you see /8. This /8 means how many number of ones are there? 8. So you have /8. The same thing for B. So this is the default subject mask for B. So that's what for B is 255.255.0.0. So when you convert it to binary, you can see that the first octet are all ones, second octet are all ones, and then the third octet and fourth octet are all zeros. If you count all these ones put together, you have /16. So what it means that when you see a network that says /16, they are telling you that the subnet max is 255.255.0. When you see something that is /8, it's telling you that it's 255.0.0.0. So you can now see how we came about this slide. And then you can see this is default class C. Please, you can note it down. This is something you just have to note down all the time. So 255.255.255.0 When it's converted to binary, you have all ones in the 3 octet, and the last octet is all zeros. And then when you count all number of ones put together, it's /24. So that's how it came about /24. Then from the fourth subnet here down to the last is what we call subnetting the subnet. The default one is 1, 2, 3, but this one from 4 down is when the original subnet has been subnetted further. I need to say this for the record. Prior to now, far back then, they were working with the class A, B, and C. But when they were running out of IP addresses, there was a need to further subnet the default subnet. And that was how we came about with all this one. So if the number of ones, now if you're interested in less number of hosts, you know, hosts are zeros, while ones are network. So here you have 255.255.128. And when you combine 128 to binary, you have 10000. So when you add all the ones together, you have /25. And if on a /25 network, if I ask you, for instance, how many host devices can be connected on /25? What you do is that you count these zeros: 1, 2, 3, 4, 5, 6, 7. You say 2 to the power of 7 minus 2. We always minus 2 because the first one is for broadcast and the last one is for network address. So if you look at this very well, this one, all 7 zeros, 2 to the power of 7 is 128, minus 2 is 126. So it's telling you that you have 126 usable IP addresses. Are we together? Are we following?
Yes.
Okay, fine. So then if you look at the second one is 1, 1, then you have 6 zeros. So you say 2 to the power of 6 minus 2. Then you now be able to know the number of host devices for a /26. So we have it for /27, we have for /28, /29, and /30. So this is how this slash came about. So like I said, either you call it slash notation, or you call it slide notation. So whichever terms you use. So the next time you say a slash, you can be able to, on your own, determine the number of 0 bits and the number of ones also. And so here is determining the network that's logical AND, because when you AND your network address, your IP address, and your subnet mask, it gives you the corresponding value, which automatically becomes the network address. So once you have an IP address, which is the host, and you AND it with the subnet mask, the resulting effect or the output is what we call the network address. So how do you get the network address? You just AND this. AND means that you are multiplying these two together. So you're saying 1 to 1 is 1, 1 to 1 is 1, when is 0, 1 is 0, like that, and then you sum it up, and then you get your network address. So you can check it out and then you see. So your IP address, and when you AND it with your subnet mask, it gives you your network address. So the video covered the following: network address, broadcast address, first usable host, last usable host. Okay, so the first usable host is the first number. Remember, the first you don't touch, the last you don't touch. The first is the network address, then the last is the broadcast address. So we don't usually assign those two numbers. That's what, so in case somebody asks you, for instance, just look at the network here. This is a network that says 192.168.10.10/24. If they ask you, for instance, on this network, what is the network address? The network address is .0, which is the first number, and then the broadcast address will be .255, which is the last number. So, but then the usable will now be in between. So when you say what's the first usable, the first usable will now be .1. So please always note this. And when I do the pre-recording I sent to us, it also help us to understand it better. So unicast transmission is when you're sending 1 to 1. That we've explained. And then we said for multicast, when you're sending to a group packet system, and then for broadcast when you're sending to all the systems. So you always note this. Very important. So types of IPv, IPv4 is divided into two types, the public and the private. The public is in the public domain, which is your internet. So for you to be able to browse on the internet, you need a public IP address. And then for you to manage your internet network, you need a private IP address. So INA is really concerned more on your public, because that is where you pay for your bandwidth and all of that. For the IPv4 and private, they just give you the range. So to your right, if you look to your right, they've actually given us the private IPv4 address. And please, you need to note this for the record. If you have from 10.0.0.0 to 10.255.255.255 is a private class A. And if you have from 172.16.0.0 to 172.31.255.25 is a private class B. And then for 192.160.0.0 to 192.160, remember when you look at the range, you discover that the first two octets here, they are the same. But the last two octets, there's some increase from 0 to 255. So this is, what we have here is a private IP address for IPv4. And any other addresses that is not captured within this is automatically a public IP address. Remember, this is class A, the second one is class B, the last one is class C. And if you recall vividly, I said for class A, any number within 0 to 127 is in class A, of which 10 falls within that range. So 10 is a class A. Then remember, we also said from 128 to 191 is class B. So 172 falls within that range. So this is a class B. But in this case, it's a private class B. Then 192, we now say 192 to 224, sorry, to 223 is class C. So 192 falls within that range. So if I give you, let me just ask this question before we go any further. If I give you an IP address that says 8.8.8.8, of course, this is a Google IP address, 8.8.8.8. Can anybody tell me whether it's a public IP address, whether it's a private IP address, or it's private or public? Can anybody tell me if it's a class A or B or C? And if you give an IP address that is 8.8.8.8, what class is it? And is it private or public? Does anyone need to answer that?
Class A and it's public.
Thank you very much. Class A and it's public. Reason being that it's actually not in this range. So once it's not in this range, but it is within the class A range, then it is public. So let me give another one again and then see if we can get it from there. If you're given an IP address that says 172.32.254.254, what is that IP address? What class is it, and is it private or public?
It's B.
172.32.254.254.
It's public.
Class B and it's class B.
Is what?
Class B
It's
and
public.
public.
It's class B, fine. Is it private or public?
Public.
So why do you say it's public? Let's hear from you.
Dot 32 is outside.
Because
Dot 32 is outside. 170.32 is outside the range.
Okay, thank you, Doc. So 32 is actually outside. So if you see, this is 170.16 here, then they're telling you that you will end at 170.31. The very moment you exceed by 1, the second octet automatically becomes public. But you have to be within the range. So being within the range, you're sure you're using private. And this is what you configure on your local area network as your intranet network should be with this. Before you now begin to apply what we call NAT, and then have access to the internet. So please always note this. It's something you need to have at the back of your mind. So most of the IP addresses you see, like if you look at this connection here, routing to the internet, you see we're using the network address translation, which is NAT, to address the public IPv4 address. So NAT is typically enabled on the edge router. So within your intranet, you're using the private IP address as mentioned. So if you look at this design, this topology we have here, you agree with me that the first one is the private class A, the second one is private class B, and then the third one is private class C. And if all of these must be able to go out to the internet, then you now need to apply what we call the network address translation. And this NAT that you see is either you must do the NAT at the edge router. The edge router is like the router that takes it out. You know, the last router on that connection that will exit it out. So it's either you're doing what we call static NAT, or you're doing dynamic NAT, or what we call port address and translation. So NAT can come as static. Static means that one system within, which is intranet, trying to connect to another system outside remotely on the other side of the network. So if one system to the other system is connecting, it is actually you're using static NAT. For instance, if in your school you have in the library you have the server as your, of course, your e-server, so your server for the e-library. You agree with me that that server must have a public IP address. And if that server also you have collaborations with other universities abroad and you're using their own e-library as well, and you're sharing resources, it means that your server in your e-library must also have a public IP address and must connect to the other server so that it can synchronize and then share resources. So when a system is identified on the network and that system must connect remotely to another system outside your domain, and one is using private IP address and the other one is using public IP address, or another private IP address in a different public domain, and such kind of connection is actually, you're going to use what we call static NAT, which is one-to-one, because for that particular reason, you just want to make sure it is one system having access to the resources of another system. Please, you need to note this, that the 127 IP address of your private class A is actually reserved for loopback processes. That is why you can be on your system and ping 127.0.0.1. Just go to your command prompt on your laptop, ping this IP address, you see it, you reply, because it's used for loopback or self-test purposes. So you need to note down this. And then the link local address, which is 169.25.0.0, is commonly known as automatic private IP addresses or self-assigned addresses in most cases when you're using DHCP. And there are no servers to issue out IP address. You require your system will just acquire any IP addresses. Some of you will have experienced that when the network is not active, you just check the system, you see the system picking an IP address. But that IP address is speaking. You will now see that it's within this range. So we call it the link local addresses. So this is for class A, for B, for C, for D, and for E. Remember, I told us 0 to 127 is A, 128 to 191 is B, 192 to 223 is C. Class D is reserved for multicast, and class E is for research. So you wouldn't need to bother yourself with D and E because they are all reserved. So the more you'll be doing is A, B, and C. Very important. This is assignment IP addresses. So we have different continents with their own IP address. Like I was saying the last time, that for Africa, which is Afrinic, we are still yet to exhaust our IPv4 address. Okay. Here we're looking at broadcast and segmentation. It's obvious that when your network starts growing, when you have app taking place, remember app is the address resolution protocol, when the system must resolve the destination MAC address through a given IPv4 address. When you have broadcast taking place on the network, after a while, you're going to have congestion. So that is why we always look at how best can you handle congestion on the broadcast domain when you use switches. One of the best way to break broadcast is to introduce router. So router helps you to break the broadcast domain. And once you're able to break the broadcast domain, another thing also is to segment the switches so that you can be able to reduce the number of broadcasts on the network. So please, segmentation is a way of reducing broadcast on the network. Remember, broadcast leads to congestion, and switches operate based on broadcast domain. What we mean by broadcast is that when you have systems connected to switches and they must transmit or send frames, they must announce it on the entire network, which automatically leads to unnecessary traffic. And then over time, it gets the entire, it leads to what we call broadcast storm. With that, there will be a whole lot of congestion, and until you restart the entire network, it will be quite worrisome. So one of the ways to eliminate this is to actually segment the network. So this is the problem, the challenges with broadcast. And then, like we said, the solution is to what? Reduce it. So reasons for segmenting network is to, what do? You subnet, reducing overall network traffic and improvement of performance. That's the SS. It can be used to implement security policies between subnet. So you can actually use it to, and then you can also, it also help for ease of management, because if you do segmentation, you can have like 8 floors. So each floor will be on the subnet, or each floor will be segmented on a different domain. And please, segmentation will only work well with subnetting. That is why you have to do some subnetting to ensure that you, using the same network address, you can subnet them into maybe 4 or 5, and then each floor will be on its own. And with that, you can be able to manage the network and apply, and then carry out some stringent security policies that can help the enterprise network. So subnet are used for a variety of reasons, including by location, group function, device type. So please, in summary, what we're saying is that segmentation helps to reduce broadcast and help to help in terms of security policies, and then ease of management of the network. So subnet and IPv4 network. So I'm going to, like I said, I'm going to do a pre-recording for this. I wouldn't want us to just be looking at the bits of zeros and ones. So I will do this, and then first in the morning, and then send it to us so that we can all go through and then see how you do your normal subnetting and all of that. So please look out for the recording of this so that we can move ahead from here. So I think that will actually address, once I'm done with that configuration, the subnetting, I'll post that to us. Then I'll also send us the exploration 4.0 so that you can actually practice that, so that you do, maybe agree that you do to solve 20 questions. So when you solve it, the good thing about it is that you check the answers to see if you're correct or not. It actually helps students a lot. I've used it with different students, and it works well for them. So I'm going to actually stop here and then give us the opportunity to ask questions. And you have the material ready, so you can go through. And then if you have issues, even before we start the next class, you can also come back again and look at what challenges you have and then address them. But please take on your assessment and try to see how you can get your grade book going, so that when we're writing the final exam, we won't have issues. So any questions so far? You guys had a long time yesterday, so I just need to make it short today. So I'm going to send that recording tomorrow to help us.
Doc.
Yes, I'm here.
If you go back a little, I saw a term as we were scrolling, VLSM. Can you speak to it?
Is it?
If you go back onto your slide.
Okay, the slide for 11.
Cover that during his video, during his he's talking.
I should go back to the slide.
Yes.
Yes.
Okay.
Where you have variable lengths of netmask.
Yes. Okay.
You can just speak to it briefly.
Yeah, okay, the variable length subnetting max.
Yes.
Yeah, when we start looking at the routing protocols, the VLSM goes a long way to help us. It is when you have, like, if you look at it, you have /24, /24, /16. These are actually more or less default subnet mask. But when the subnet mask begins
They are
to
fixed
vary,
length.
hello?
Yeah, I'm listening.
Okay, I said they are
Yes.
fixed length, bro.
Huh?
I said those ones are fixed length, fixed /16,
Yes. What I'm
/24.
saying is that if you have a particular topology where you have
Yes,
maybe all of them on /24, that is they are fixed length, and that is, we call them classful network. A classful network is a network that all the subnet marks or the subnet length are the same. Is that okay?
yeah.
And then when you now have the one that is varied, what I mean is that one portion of the network is /28, another one is /27, another one is /6. Automatically, that is what we call the variable length subnet mask. It's telling you that in this case, everybody is not on the same fixed subnet mask. And what has made it vary? What has made it vary is based on the requirement. For instance, if you design a network and the headquarters is in Abuja, and then you have a branch in Lagos, Kano, and Port Harcourt, for instance. In Abuja, there you might say, oh, in the headquarters, you just have 6 users. And then in Lagos, you have, let's say you have 30 users. In Port Harcourt, maybe you have 60 users. And then each of them, you want to manage the public IP addresses. So you're going to actually calculate it to suit the numbers that is needed there so that you don't waste IP addresses. Because remember, when you're paying for bandwidth, you also pay alongside with those public IP addresses. So you now want to say, no, in Lagos, they just need 30. They need 30 hosts. In Port Harcourt, they need just 62, for instance. So how do I now work? So once you work out for Lagos, Port Harcourt, you now discover your subnet mask will no longer be fixed. In this case, it becomes variable. So let me just take it back again so you see.
It's clear. Okay.
So we're there already, right? So this is the VLSM he requested for, which is variable length subnetting mask. I was still going to talk on this in the next class. I'm not ending it directly, but let me just throw more light on it. So if you see here, and one of the ways to conserve IP addresses is to introduce the variable length subnet. Because for the fixed one, for instance, when you say /24, you can imagine when you want to do a connection between R1 and R2 where you have just 2 hosts, and you now have a /24. Also note that 24 is like 254 usable IP addresses. So when you assign 1 and 2 here, the remaining 252 will be wasted. And if it's wasted that way, it is not good. And then even though you configure it, you now also realize that the router will be doing what we call update. And if it's doing update, it's updating all the 254 IP addresses, of which is only 2 that is needed, from what you can see here. So router to router interfaces require only 2 hosts. So that actually calls for conservation. And the conservation is what led to variable length subnet, because you are now actually working it based on the requirement. So in my pre-recording, I'm going to do that calculation to also let you know how you can, like in this case, I think I'm going to use this one for the pre-recording. So you can note the slide 58, where you have 25 hosts. And in this case, it's /27. How did you arrive at 27? And then you have 20 hosts, /27 here. And then you have 15 hosts. So you could see here that from 25, 20, 15, they are all the same, because somehow the number fall within a range. So this one that is /7/7, we refer to it as, of course, you won't say this is variable length subnet, because this automatically is in the same category of range. So this actually will come as classful. And in the routing protocol, classful network are specifically for information. Classful network are specifically for routing information protocol. So the routing information protocol uses classful. Then when it's varied and it's based on the number of users, that is where you bring in some routing and concept like OSPF and ERGR. So note here that the variable length subnet has its own application, and there are certain routing protocols that work with them. They don't work with classful. So classful is when all of them have the same slide notation, and then when it's varied, it is classless. And when it's, I mean, you can also call variable length subnet a classless network for information, because the subnet max varied from one point to the other. The application of it is when you will now be doing configurations for the different routing protocols. So that is where you now apply the variable length subnet. So I think that actually will help. Like I said, I want to do those calculations so that I will play it also in the next class, which is tomorrow, for us, or you could watch it on your own and then let me know if you have questions in this.
Sir, may I suggest that?
Yeah, please go
that
ahead.
For this understanding, like where we have 25, 20, 20, all these things.
Is it?
We may, I say for better understanding, can we make, just when you are taking, can you change this one, like that 20 make it 10, and that 15 make it 5, so that the variable will clearly.
Okay, the variable will be obvious, right?
Yes, it will be
okay,
obvious.
So what I'm going to, thank you.
And we will all see that slash with all of them will not be slash.
I quite agree with you. If you can, what I just say is that instead of us maintaining the same slash 27, let's increase. So this first one, we will leave it at 25. Then this one, we're going to work with 62. This one, we're going to work with 126, like that. And then this one will work with 6.
Okay.
So that.
And it also help us, you know, this orderliness, when you are doing variable length subnetting, it will help us that we will arrange, the way we will arrange based on the needs, based on the number.
Yes. No, sure, I will. In fact, I'm going to use this whole, what I just told us, like having a company that has headquarters in Abuja, have branches. So the question is going to come in that form so that you can see from a practical approach rather than just. So that you now have 6 users there. So how do you work for 6 users? And remember, the block of IP address will be 1. So they could give you 192, maybe 193.169.20.0/24. So how are you going to break down that network address to cater for all the branches, you know, across that company? So you're going to look at it based on the need for every particular branch, and then resolve it based on that number, and then populate it on your routing table, and then that's what you now use to. So I think I'll use that approach, which now makes it clearer, because that's when you now know how to apply it, so that you don't just see that it's something that you just calculate and leave. No, subnetting is very important. So if it's still the same subnetting processes, but the point now is that it's going to be varied. It's not going to be the same. So once the subnet max or the subnet length is not the same, then you now know you're using variable length subnet. So I don't know if that was okay for Dr. Moses. I don't know if you're okay with this before.
Yeah, it's okay. Thank you very much.
Yeah. So any other question, please?
Thank you.
Yeah, thank you. Any other question? So I'm also going to do this for the VLAN configurations. It will help us a lot. Please note this, because this, when you do this subnet too, also note that it can be used for VLANs. I'll just chip in that as well, because once you subnet, you can, the segmentation we're talking about, you can also assign each subnet to a particular segment, and that will also help. So all of that will be mentioned in the course of the calculations to help us a lot. I think that will actually help us to, when we're reading through module 11, we won't have issues. So I don't know how many of us have actually attempted up to module 7. I mean, you've done your grade book, you've done up to reach module 7. Nobody. Nobody.
I've done it, sir.
It looks like none of us.
Okay, none of us. Wow.
I did.
But how do we
Osman has done it.
But how do we find this course? Is it difficult? Is it okay? Are there challenges that we need to look at as we go on? I can also assure you that when you read the curriculum, it also comes handy as well. Hello, are we there?
Yeah, we're together. The course is quite interesting. We love it.
Yeah. We need to do this.
We need to practice and do the exams.
What I would do is, I don't know, it's like the lab is overwhelming us. If not, I actually have plans to be dropping one lab as we go. Just drop a lab. You know, you do the configuration and then on and on. But then what I do for my students is that I usually give them a lab, like a project that I part with. So I'm going to do that here in this class. Once in the next 2 classes or so, we'll round up with the whole 17 modules. I want to now do a project, a lab project, which I want everybody to do a presentation on. Everybody will practice it, and we'll fix a day for the presentation so that you do it yourself and know how to design it and to help you. So that lab will actually address the CCNA1 completely. It's like somebody gives you a router, for instance, and tells you, okay, this is Baze University, you've acquired a Cisco router. How do you configure this router, connect it to a switch, ensure that they are on different VLANs, and maybe some to the hostel, a different network, and that subnet also to maybe to the Senate building, and then to the staff offices, and then they should be on a wireless network and should be secure. So we're going to look at that design, addressing an institution or addressing an enterprise, and then develop it with a particular IP scheme, and then configure it from start to finish. And then everybody should have it saved. I will do it myself, live, virtually rather, and then give everybody the opportunity to do it themselves using a different IP block and maybe changing 1 or 2 things. So if you're able to do that on your own and you do the presentation for me, I think I'm good, because that lab will actually address a number of things, which anybody can take home. At every point in time, you can pick router switches and configure it for any organization, and then you're good to go. While I'm giving you that, I also want you to use the same lab, possibly even scale it up, possibly, for your students, and let them know that at the end of the course, they have a lab project that addresses industry need or addresses enterprise or any organization, so that when they finish CCNA1, they can beat their chest, that they can actually set up internet in any organization without looking back. So CCNA1 should be able to do that for them before they move further for CCNA2 and into CCNA3. So please, you get ready for that lab.
That would be very lovely.
No problem, sir.
Okay, so thank you all.
Okay.
And I wish you
Thank you, sir.
good night rest.
Okay. Bye.
Okay.